demographics, population demographics. Never the twain shall meet when I was an undergraduate. And then we'll talk about the future. How are we going to pull these different, seemingly quite disparate disciplines together to form a better future for everybody? So, firstly, I'll present some questions. I pose these questions to our undergraduate civil engineers. I usually get fairly blank faces. So I think, like me, when I was an undergraduate civil engineer, a very vague idea of what civil engineering actually entailed. So what's a civil engineer? What's civil engineering? What does a civil engineer do? All very pertinent questions if you're going to devote 3 or 4 years of your life to study. Just a little introduction about me. So I've already covered the details. That slide's out of order, isn't it? Okay, so moving on. You already know that. So what is civil engineering? So when I was an undergraduate, first lecture on the first day, lecturer provided us with a picture like this statement on it, and asked us what civil engineering was. From memory, I thought, I wonder if it's the art directing the great source of power in nature for the use and convenience of man. One bright spark at the front stuck his hand up and said exactly what's written there. He went on to become top student in the class from memory. I think today he might be pinged for plagiarism, just reading it out, but that's by the by. So this was a statement or a definition when the Institution of Civil Engineers was set up in the early 1800s. So it's identifying what the object of a civil engineer is. In broader terms, civil engineers are not military engineers. Traditionally, the military engineers built the roads, built the dams, built the bridges to enable their armies to get to the wars. And we're not at war, we'll get civil engineers to do the same job. And what does it entail? So, 2 key requirements. Quite tough being a civil engineer. There's only 2 things you have to do. First thing is it mustn't fall down. So you have to make sure whatever you make will carry all those that you put upon it. Yeah, so that may sound easy enough and may interest you to know that in a building like this, it's a reinforced concrete building, we use the strength of the concrete, but statistically, concrete's a bit variable. So we'll always work on our 90% confidence limits. So that means at least 95% of the concrete in the building is stronger than what we design it to be. The other 5% gets that. So 5 buildings out of 100 may not be strong enough. Just to be on the safe side though, when we're working out what W is, what loads, we'll assume we've actually got 50% more than we expect. So if we've got a room full of people, we've only got 50% bigger people, rugby players instead of skinny students, or maybe we've crammed 50% more students into the space. If we try and cram 50% more rugby players into the space, then we could be in trouble. Then just to be on the safe side, we'll assume that once we've designed it, it's actually stronger or not as strong as we designed it to be, so we'll make it stronger deliberately. And that will get us to 99% of our strength. So that means only 1 out of 100 buildings will fall down. So we're much better space now. The other thing we have to do is make sure it comes in at cost or under budget. And as a rule, we're reasonably good at the first one and typically 2 to 3 times off the mark on the second one. So that was how I learned civil engineering. That's what I did. That's what everybody did in those days. We didn't have computers to complicate matters. So you envisage you're standing on a hilltop, your hat on and your glow vest, surrounded by your doting underlings, watching your structure gradually arise out of the ground, occasionally having to deal with some minor issues that haven't been overlooked at the design stage. So this is civil engineering. It's quite easy. We build stuff. All the stuff that makes society. Hard infrastructure. If it's hard, made of something, we build it. That's what we do. So it's a very inclusive, very far-reaching discipline. So we talk about hard infrastructure, but this is traditional civil engineering, which is all the stuff that connects us, where we live, where we work, where we do what we do. But in recent times, we've started to talk about soft infrastructure. The soft infrastructure is the stuff that actually happens within that hard infrastructure. This is the people, the activities that the people undertake. And if we design hard infrastructure without taking that into account, then we're not going to get good solutions to what people want. Society is the ones that use it, that need it. If we don't get it right, then they can't function effectively. So it's become quite apparent to us from a designing point of view as civil engineers that we're not just looking at hard infrastructure and loads, we've got to look at interaction with people, groups, communities, cultures, and so on. So we change now from our two basic requirements to having to look at a whole load of other considerations as well. Think about the environment, culture. We've got to think about historical values. We've got to think about climate crisis. We've got to think about legislation. So there's lots and lots of additional considerations which are all interlinked, all relate to how what we do relates to communities that we're serving. And we need a crystal ball. We need to see the future. We're going to design stuff today. It's going to be built tomorrow, last for 100 years. You've got to have an idea of where society's going. And what's the future look like? Pretty gloomy from some analysts. Yeah. This has prompted a change in our definition of civil engineering. This is a recent definition. Actually only changes 3 words in that original 1828 version, but it subtly alters the meaning. It means that civil engineering is much more responsive, much more aware of its impacts and how that will affect the solutions. I asked my graduates this question, famous civil engineers. I asked if they know any famous people, TV personalities, politicians, pop stars. They can usually reel off a whole list. Famous civil engineers. I asked that question and there's usually quite a few blank faces. Does anybody know any famous civil engineers? Well, why should you? There's a list of names. There's the top 12 from the Institution of Civil Engineers. There may be 1 or 2 there that you do actually recognise. And having identified those, you'll see that most of them are 18th, 19th century age. There's a few more modern ones. And they're all famous for various reasons. So Brunel was a big railway man. Smeaton was Edison Lighthouse. Eiffel, heard of him, I hope. You also know he did the Statue of Liberty. And so all of these are important for various reasons. This guy was around at the time of the Emperor Trajan in Rome, so there was a lot of infrastructure built then. Some of these others quite prominent in their time for specific things. Get down to the bottom, notable by the fact that it's the only woman on the list. Anybody like to hazard a guess at what she's famous for? She's famous for being the first female member of the ICE. She was chartered in 1927, 99 years the institution was chartered. She was 1 out of just under 10,000 chartered engineers. The reason I show this is because 1 out of 12 is not far from removed from where we are today. And so when I was an undergraduate, there was 4 girls in a class of 80, 5%. Most of the classes I teach these days have between 5 and 10% female representation. I think 20% of the graduates nationally are female, 5% of our chartered engineers are female. But half the population is female. If we go back here, we're looking at being inclusive, we're looking at understanding problems from a broad range of perspectives. If we don't include half the population, then we're limiting the potential for the solutions. So unless we change the demographics there, we've got to work more towards that inclusivity, finding opportunities to get more involvement, more engagement. We have some research projects running currently, looking at what the drivers are, what the barriers are, trying to understand what process we can adopt to engage more diverse genders into the profession. I personally think part of the problem is we make it too hard. It's a manly thing. We feel that we can do complicated maths that nobody else can. And if you look at that image, there's very little maths involved. A lot of it's communication, a lot of it's awareness, a lot of it's understanding people. We find that members of the opposite sex, from my perspective, are a lot better at doing that. Engineering is not just about doing sums, it's about understanding communities, communicating, developing ideas. So we need to definitely engage with both halves of the community. Okay, so let's just think about changing demographics. I have to admit, not being a demographicist, I had to Wikipedia it. But it did occur to me that our hard and soft infrastructure divide does to some extent reflect how population demographics work and how they change. So we have sort of physical changes. The numbers change, the ages change. So there's those measurable, quantifiable things. And we've got different activities that people undertake. So how they occupy themselves. And then we've got some of those more subtle individual characteristics that are more personal. And we have to recognize that there's a whole different array of characteristics that we're looking at. And on the basis of that, what is changing? How is it going to change? And what do we need to change in the way we engineer the future? Yeah, so if we look ahead, if we get our crystal ball out, polish it up, put some new batteries in, and try and project where society is going and where it needs to be. So what do we need to put in place now to ensure that there is capacity, that it meets the demands? We'll look back in the past a little bit. The past is not a good indicator of the future, but it does give us some ideas about how things change. This is a photograph of a little place on the east coast called Tokomaru Bay. If anybody's heard of it, it's just a little bit short, a little bit north of Gisborne. So in the early part of the 20th century, it was a booming town. The local farmers built a freezing works. All their livestock was taken to the freezing works for processing, and then it was shipped out. They built a big wharf. At the time, there wasn't very effective land transport. Population grew to over 5,000, range of meat workers, and service industries. After the Second World War, there was an increase in land transport, changes in technology, local processing died out. So all that's left now is a few ruins and a population of a few hundred people. So dramatic change in demographics. Those few hundred people are a wide range of cultures, age groups, and interests. One of the interests is exploiting these ruins, preserving them, preserving the history, rewriting their story, creating a new chapter in who they are, their identity, what they want, where they're going. There's a young generation as well. They see the recreational opportunities of leaping off the wharf and fishing. The local council sees potential for heritage tourism. So there's a new demographic there that's driving to actually see something happen to these in a positive way, rather than just letting it decay and fall into the dust. And recent events have also identified that eroding networks not actually that resilient or robust. So having facilities to use coastal shipping to supply these small settlements actually is an opportunity. So for some of these situations, we may be looking at a future where there's less dependency on the traditional transport, and we shift back a few generations to a different way of doing things. So going back to our changing demographics, as a historical snapshot with some possible future connotations. There's some fairly obvious ones. When I Googled it, these were the ones that tended to stick out. Population growth, of which it's aging. I don't know if any of you have noticed, but there seems to be less and less old people around and more young people. That's a sign that we're aging, I think. My mother observed it. One of our relatives passed away recently. She's now at the top of the pile. She's the oldest one in the family, so she's looking down on us all. We also have digital disruption. I'll include this as a demographic driver or changer. So what does population growth look like? Population growth means infrastructure growth. We have to accommodate people, we have to provide people with opportunities, we have to provide people with education. So any future growth has to, as far as we're concerned, align to the UN Sustainable Development Goals. We need to be doing things the best way we can and as sustainably as we can. If we look at that in terms of our cities and communities, what does growth look like? What's it going to look like? How can we manage the increasing number of people, make sure they've got places to live, places to work, places to be educated? Another little history lesson. After the Second World War in the UK, there was a housing shortage, partly because a lot of housing had been destroyed during the bombing, but also there was a bit of a baby boom. During the Blitz, the lights out, it's very dark, you have to go to bed early, what do you do? Well, strangely, all these babies appeared. So we needed more accommodation. Between 1946 and 1947, they built 150,000 homes. Just in the course of a couple of years, there's a huge number of homes to accommodate those people, replace a lot of those damaged, war-torn buildings. But it wasn't necessarily the best way of doing things. So in the 50s and 60s, we started to go to higher density housing. It's a sort of familiar situation. It's faster to build. You can build lots of them in a short space of time. You're making better use of space, going up rather than down. And it's usually lower cost because you can replicate everything. Economies of scale. You only have one roof on the whole building, not individual roofs on every floor. Yeah. So basically, it's a really good solution. From an engineering perspective, it's a winner. Yeah. We've met both of our parameters, stands up, and it's cost effective. There has to be a but though, doesn't there? Okay, but in this case, somebody left the gas on, and then when they went to boil the kettle, they blew their kitchen out, which took down all the kitchens, the floors below and the floors above. People are not happy when they get up in the morning and go to make their cup of coffee and the kitchen's disappeared. Yeah. So from an engineering perspective, yeah, we didn't quite get the first bit right. But what they also discovered here, that from a social perspective, it wasn't a good solution. Yeah, people weren't used to being crammed into a small amount of space. If you look in the background here, you can see the traditional housing, terraces. Everybody knew their neighbours either side. Everybody had a little bit of a back garden. There was a bit of space around to park your car, some open spaces for your kids. All of a sudden, we hundreds and hundreds of people into a very small space, very little maintenance or poor maintenance, and they just deteriorated. They were not a good solution the way they were done, aside from the structural defects. And so we need to take this on board. We can learn from the past and hopefully not repeat those mistakes in the future. Works in some places, don't get me wrong. But if we've got populations that are accustomed to low-rise living, it's quite hard to convert them to high-rise living. So what's the sustainable living going to look like? We've grown population, we need more infrastructure. What does it look like? What is it we're providing? It's going to be fit for purpose. It's going to have to serve an aging population. It's going to have to serve an immigrant population. They have different requirements. One size does not fit all. Where's it going to be? According to the UN, I think it's like 68% of people will be living in urban areas by 2050. The Google search, 89% of New Zealanders live in urban areas already. And there's suggestions that there will be a de-urbanisation. People will move out of the big cities, especially that aging population who don't need to live and work in cities. We've all experienced disruptions from COVID-19. Realised that, well, we don't all need to be stuck in the big city. Yeah. Big cities are a 19th century solution to 19th century problems. Communication, interwork between people. 21st century, we don't need to live and work in the same places. And we have to think about the effect of natural disasters, as recent events have shown. How do we do it? We need to use sustainable materials, sustainable methods. What are they? How do they work? Do we have them available? We'll just talk briefly about ourselves in a few years' time. Actually, I feel like that most days, but what do our aging population want? What's their aspirations and needs? We can't just build some more Hilda Rosses. That may suit some, may not suit all. Definitely more independent. They're living longer. Some of them have more disposable income, but not necessarily all. They're not all going to need 4 and 5 bedroom homes. Yeah, so different requirements. They're possibly less mobile. They need to be in places where they have access to those services they need. So they may be more inclined to use public transport. How do we ensure that that's available? They may need increased healthcare. They may want assisted living. And as we have an aging population, then the requirements of our medical facilities may need to change. May need more specific facilities, specific units to actually do that. So we've got a lot of things to think about here. So we're not just thinking about putting roofs over heads, we've got to think about how those roofs are connected to the rest of our towns and cities. Where are we going to live? Where are all these people going to live? This is a Wikipedia map showing the population distribution. The reddish bits are the population densities, just in case you're not sure, you're there somewhere. So most of our population is very much concentrated on a few locations, most of which are centred or close to the coast. I'm sure we've all heard media reports of problems with sea level rise and how that's going to affect our communities. We also have to think about, in the light of recent events, what about other natural disasters? Where is it safe to build? Where can we build that's actually going to be suitable, not just now, but in 100 years' time? I'm not a statistician, to be honest, but it's part of our teaching, we have to talk about probabilities. When we're designing things, we have to think about the likelihood of events taking place and the consequences. So if we look at some basic calculations, most structures will talk about designed either for 50 or 100 years. So if we're designing for, say, a 100-year flood, we need to know how likely it is that our design will be affected by a 100-year flood. Of course, the natural response is, how often are we going to get a 100-year flood in 100 years? Well, once, really. Except it's not that simple. So we have this relationship here. You're not a mathematician, apologies. But basically, the probability of something not occurring is given by that equation. So that means the probability of a 1 in 100-year flood not occurring in 1 year is 0.99 or 99%. So that means there's a 1% chance it will in 1 year. What's the chance of it occurring in 100 years? So there's a 63% chance that a 1 in 100-year flood will occur in 100 years. That means there's a 37% chance it won't occur, but basically it's a 2 to 1 chance it will. And so when we're thinking about 1 in 100 years floods, we're not thinking about one event every 100 years. We could have 2 events in the next 2 weeks. It's not a uniform distribution. If we take it to a bigger number, we've still got the possibility, even if it's a 1 in 1,000-year flood, there's a 10% chance it will happen in the design life of our building. So what does that mean? Very simple terms. As an engineer, do I design, move somewhere else? Might not be the best place to put it. Or if this is my 1 in 100-year flood, do I make sure that my floor level is up here? So we don't have to move away. We just need to design right to deal with the situation. I used to live in Henderson Valley, Aotearoa Ranges. Land I was on had a 1 in 50-year flood risk, which means we've got about 2 significant floods each year. Not once every 50 years, 2 a year. And the water used to come up about that high, which was fine because my house was on stilts up here. My lawnmower used to get wet and the other stuff under the house, but the house was designed to deal with the environment. But we have to think about that when we're designing our infrastructure for the future. We can't move everybody to high ground. May not work, but we can be smart about what we put and where we put it. Anybody heard of this? Climate Change Commission? Yeah, so 2021, they issued this draft advice for consultation. So it relates very closely to what we're doing, but it also relates to the population, people's concepts, their ideas, their engagement. The environment has become a high profile for a lot of people. So we need to be conscious of that and we need to respond to that. This is what the Climate Change Commission has to say about construction. That's it. Doesn't have anything to say about construction at all. It's all about farming emissions and vehicle emissions. It's a bit of an elephant in the room, really. They asked for consultation from Engineering New Zealand, and I submitted, this is an elephant in the room. I can't see anything about construction. I'm a concrete man. Concrete, that's the law building, I think. Now look too closely, you'll see the cracks. So construction is responsible for about 20% of New Zealand's emissions. Yeah, so we can't ignore it. We've got to do something about it. We've got to respond to the population, society that wants action. We've got to respond. We've got to be seen to respond. We've got to do everything we can. Living in caves is not an option for most of us anyway. Concrete globally is responsible for about 8% of CO2 emissions. The New Zealand concrete industry has made a commitment to reduce emissions by 25% by 2030. And we're looking at alternative cements, alternative processes, more efficient use of materials and so on. There's a commitment from us to do something about it, and they're well on target to do that. Really opens up opportunities for innovation. Engineers are supposed to be good at this. If we know what you want, we can engineer it. That's what we try and do. This moves us into the digital space as well. I mentioned digital disruption earlier. So, fix that. Okay, so this is the future. Decide if we've got this, then makes teaching a whole lot easier because we can just plug a disk into our students and they'll walk out knowing all the information. Somebody did point out that if we do that, they might be able to replace us with robots as well. So there's a lot of technological advancements in place and developing and coming. In civil engineering, we're looking at what we call building information modeling. We're looking at construction 4.0, digitizing everything we do, recording it spatially in the digital world. All of our drawings, contracts, designs can be digitized and stored. All the processes that we go through can be stored and retained in a digital format. We're also talking about virtual reality and augmented reality. What that means is that for an average person, we can present them with a lifelike image of our proposals. They can walk through the buildings we're proposing without us having to build anything. Put on a headset or engage in a program which will allow them to actually work their way through. They can see what it's going to look like. They can say, well, that's no good because people are in the wrong place. Seats are in the wrong place. The entranceway is too narrow or too wide. Yeah, so we can engage more with people. It's also going to have a big impact on our workplaces, on our education. And so what will our people be doing if we've got machines doing the work that they currently do? It means we've got to think about the opportunities there. What are the educational requirements to meet this future workforce? If we need people who can maintain robots, we need people who can control them, program them, and so on. So it changes the focus, it changes the requirements. It opens up a lot of opportunities and a lot of challenges. And there'll be a lot of people discomforted by it. So if Luddites around in the good old days, will be the equivalent moving forwards. We already have robots being developed at the university here that will pick fruit. They'll replace the orchard workers. Subsistence level incomes for some people. What's that going to do to our population demographics? We have to be thoughtful of that as well. Technology needs to be applied with a certain moral compass, I think. It provides us with some really useful tools, though. So following the Christchurch earthquake, the council collected information from residents on what they wanted for their central city. It asked them to give all the stuff they wanted to see, public transport, open spaces, public buildings. They wanted to know what people thought so they could come up with a plan that reflected the population. They got hundreds and hundreds of submissions. And it's not practical to go through all those. So here at the university, we developed an AI tool which could go through those submissions, look for keywords, identify those, link those with the different hard and soft infrastructure categories, work out what the priorities were, what people were looking for. And that's represented in this chord diagram here. On the left-hand side, we've got soft infrastructure, the right, hard infrastructure. Different categories of those and showing the cross linkages, what's important to people. And that we can use when we're designing to actually come up with sound solutions that are based on consultation with the population. Moving to the future, we have this construction sector accord. So we're not blindly moving ahead. We have a relationship, an accord between government and industry, basically saying we've got a job to do. We have to provide and continue to provide the infrastructure for the growing population, for the changing population. We need to make sure we do it right. We've got to look at what is important in this sector, specific to New Zealand. We've got to look at supporting people and communities, both in the workplace, in the construction sector, but also in the community generally. We have to produce solutions that people want and need. We've got to look at making sure we support our climate change and environmental responsibilities. And we also want to have a productive sector. Construction is fairly low on the productivity ratings. We've got to look at ways of raising that productivity so we're more efficient, more effective, more cost effective. We've got to be responsive as well. So recent events have shown us that the world is changing, potentially big ways. We've got to make sure we respond to those properly and use the available data and information. I don't think when they wrote that, they actually were considering demographic or population data. But I think that's really vital to ensure that we achieve what we need to achieve. I'll just sum up now. So society is changing, we've got growth, we've got aging, urbanisation, we've got lots of changes visible or coming, which we need to allow for. And construction is changing as well. We're having to adapt, we're having to become more focused on what people need, more people focused, and we need to recognise that for us to do our jobs properly, we need to have a clear view, a clear understanding of what the world or our population is doing and needs.